Ceramics. The word ceramic is derived from the Greek term keramos, which means the potter's clay, and keramikos means the clay products. Till 1950s, the most important type of ceramics were the traditional clays made into pottery, bricks, tiles, etc. Ceramic artifacts play an important role in historical understanding of the technology and culture of the people who lived many years ago. A ceramic material is an inorganic, non-metallic material and is often crystalline. Traditional ceramics are basically clays. The earliest application was in pottery. Most recently, different types of ceramics used are alumina, silicon, carbide, etc. The latest advancements are in the bioceramics, with examples being dental implants and synthetic bones. The comparative analysis of ceramics with other engineering material is shown in the table in the next slide. The purpose of presenting this comparative analysis is to show importance of ceramics among different engineering metals and polymers. This comparison would enable to justify the application areas of the ceramics. In terms of the property, the lowest density is of polymer. Then we have ceramic, and then we have the highest density of metal. In terms of the hardness, the lowest is polymer, then above that we have the metal, and on the highest we have the ceramics. Ductility. The metal and polymer are highly ductile, whereas the ceramic is low in ductility. Wear resistance, we have the metal and polymer onto a lower or low wear resistance, where the ceramic is on a high wear resistance. The corrosion resistance, same as the above. The metal and the polymer have low corrosion resistance as compared to the ceramics. The thermal conductivity and the electrical conductivity are the polymers who have the low thermal and electrical conductivity, then we have the metal which is high, and then we have the ceramic which is mostly low. The applications: the pottery products, sanitary wares, floors and roof tiles, crucibles, linings and other refractories. High-end applications such as in ceramic matrix, composites, tiles, in space shuttle, bulletproof jackets, disc brakes, ball bearing applications, and bioceramics. Let's talk about the classification of ceramic material. The ceramics can be classified in diverse ways. That is, there are a number of ways to classify the ceramic material. Most commonly, the ceramics can be classified on the following basis: the classification based on the composition and the classification based on the applications. The classification of ceramic materials are shown on the screen. If you talk about the classification based on the composition, we have silicate ceramic, oxide ceramic, non-oxide ceramic, and the glass ceramics. In terms of the application, we have the glasses, high performances advanced ceramics, traditional vitreous ceramics, cement and concrete, and natural ceramic. In terms of application, if you talk about the silicate ceramic in glasses, the containers, household optical glasses, oxide ceramics, high performance advanced ceramics, we have the sensors, engine rotor, valve bearing. In terms of this non-oxide ceramics, traditional vitreous ceramics, etc. Now, on the base of the composition, we can also classify the silicate ceramics. The silicates are materials generally having composition of silicon and oxygen. Four large oxygen atoms surrounded each smaller silicon atoms as shown in the figure. The main type of silicate ceramics are based either on the alum silicate or a magnesium silicate. Like this, we have 1, 2, 3, 4 oxygen components, and this is the silicate. Out of these two, the former include the clay-based ceramics such as porcelain, earthenware, stoneware, bricks, etc., while the latter consists of talc-based technical ceramics such as the stilite, cordierite, and forsterite ceramics. Silicate ceramics are traditionally categorized into coarse or fine and according to water absorption into density, more than 2% for fine and more than 6% for the coarse. Or the porous ceramic is less than 2% and less than 6% respectively. Classification based on the composition, we have the oxide ceramics. The oxide ceramics includes alumina, zirconia, silica, aluminum silicate, magnesia, and other metal oxide based materials. These are non metallic and inorganic compounds by nature that include oxygen, carbon, or nitrogen. Oxide ceramics possess the following properties: high melting points, low wearing resistance, an extensive collection of electrical properties. Now let's talk about the classification based on the composition. These types of ceramics are available with a variety of special features, for example, the glazes and protective coating, seal porosity, improved water or chemical resistance, and enhanced joining to metal or other materials. Oxide ceramics are used in a wide range of applications which includes material and chemical processing, radio frequency and microwave applications, electrical and high voltage power applications, and foundry and metal processing. Aluminum oxide Al2O3 is the most important technical oxide ceramic material. This synthetically manufactured material consists of aluminum oxide ranging from 80% to more than 99%. You can see over here the aluminum oxide in figure 3a, and in figure 3b we have the structure of the aluminum oxide. Non-oxide ceramics. The use of non-oxide ceramics has enabled extreme wear and corrosion problems to be overcome. Even at high temperature and severe thermal shock conditions, these types of ceramics find its application in different spheres such as pharmaceuticals, oil and gas industry, valves, seals, rotating parts, wear plates, location pins for projection welding, cutting tool tips, abrasive powder blast, nozzles, metal forming, tooling, etc. The glass ceramics. These are basically polycrystalline material manufactured through the controlled crystallization of base glass. The glass ceramic materials share many common characteristics with both glasses and ceramics. The glass ceramics possess an amorphous phase and more than one crystalline phases. These are produced by a controlled crystallization procedure. The glass ceramic holds the processing advantage of glass and has special characteristics of ceramics. Glass ceramics yield an array of materials with interesting properties like zero porosity, fluorescence, high strength, toughness, low or even negative thermal expansion capacity, pigmentation, high temperature stability, dielectric, low dielectric constant, machinability, high chemical durability, biocompatibility, superconductivity, isolation capabilities, and high resistivity. These properties can be altered by controlling composition and by controlled heat treatment of the base glass. You can see on screen some examples of ceramics. Thank you.